All right, so we are doing chapter 11, correct? Yeah. So chapter 11. All right, well, let's go through. It's actually a 2-page test. It's not that it's any longer. It's just I had big pictures drawn on there. I didn't want to draw them real little, so it's 2 pages, but it's still only 20 problems, so don't get upset about it or that. Come on. Anyway. Okay. All right. Number 1 is all about area, right? Area of all these different figures. So 1 and 2 is just the area of a parallelogram. All right. So 1 and 2 is the area of a parallelogram. Area of parallelogram. Parallelogram. There we go. Do you remember what the formula is for area of a parallelogram? It's just the base times the height. What has to be true about the base and the height, though? Do you remember? They got to be perpendicular. So I'm not going to give you like specific examples, but I'll just do some general kind of stuff here. So if this is your parallelogram right here, let's see, and we call this the base from here to here, which one's the height? Is this slanty one right here the height? No, it's from the top. What? Not straight down, but what do we say? Perpendicular to the base. All right, so that would be the height, this red one right here, and this bottom one right here would be the base. Now you got to be careful because they don't always just give you the base and the height, do they? Sometimes they make you work a little bit at it, and I'm not going to go through all the different possibilities, but you might have to find the height. You might have to do a little trig. They might not give you the height. They might give you an angle here or something, okay? They might give you this length right here. If they give you this length right here, that's not the height, is it? It's the hypotenuse to a right triangle. So, it all depends what they could give you. They could give you all kinds of different stuff. All right, so that's 1 and 2. All right, let's see. Number 3 is kind of the same thing, except on number 3, they actually tell you the area, and they ask for either the base or the height. Okay, so on this one, you're going to actually find the area. You actually have to find the area. On number 3, they give you the area. They give the area, and you have to find either the base or the height. And that's not that big of a deal, is it? If you know your formula, this, and if they give you the area, and you can find either the base or the height, what do you do? What if they ask you to solve for the height? What do? Divide by the base. Easy. Yeah, they're going to give you the area. They definitely give you the area, and you're going to have to find the height. Now, they may not tell you exactly what the base is. You might have to figure out what the base is by doing some trig or Pythagorean theorem or something like that, okay? But eventually, once you find the base, you just divide the area by the base and you're done, okay? Pretty easy, right? Okay, 4 is a trapezoid. So number 4, area of a trapezoid, correct. Area of a trapezoid. All right, and do we remember what the formula is for area of a trapezoid? Remember, T's kind of like triangle, isn't it? So what is it? 1/2 the... Right, it's the... We'll go base times height, but what is the base, though? There's not just one base to a trapezoid. How many are there? Right, there's 2 bases, so you add the 2 bases together to get the full base. Right, so remember, T trapezoid, T triangle. You know area of a triangle, right? It's right on the... I'm going to keep that up there, okay? I mean, you should have that memorized anyway. It shouldn't be that much help to you. But it says area equals 1/2 base times height. Do you see that? That's of a triangle. But a trapezoid is kind of like a triangle, except it's got 2 bases. So you add the 2 bases together. It's pretty easy to remember, isn't it? All right. And that's it. Now, you may, like I'm looking at number 4, they don't tell you the height. But they tell you some other stuff. You have to find the height. All right, so again, you might have to use a trig function, special triangles, Pythagorean theorem, okay, whatever is at your disposal to be able to find the height. So they do give you both bases on number 4 and you got to figure out what the height is. Once you figure out what the height is, you do all this, then you get your area. Got it? Okay, so you are finding the area on number 4. Number 5, you're finding the area of a kite. Remember the area of a kite? Area. Right. And what is the D1 and the D2? That's your diagonals. Okay. I guess I should, let me grab a picture. Let's see where to put the kites. Put the kite over here. Okay, let's get back to this. All right. Let's make that a little thicker. And so what are the D1s? The D1 is, see this line straight across like that? That's one diagonal. This is another diagonal. So what do you do to find the area of the kite? Just multiply those two things together. Take half of it. Don't forget to do that. And then you've got the area of that kite. And number 5 is straight up easy. Okay, they give you the diagonals. They give you the 2 diagonals, so it's really easy. You don't really have to figure out much. You just have to know the formula for it. I am not giving you these formulas on the test. All right, there comes a point where you should memorize a few things, and this is a time where you should memorize. Everybody good with that? All right. Number 6, area of a triangle. We kind of talked about area of a triangle already, but we'll write down the formula. Area of a triangle. And what is the area of a triangle? 1/2? Good. Base times height. Or if you want to write it like this, base times height over 2. It's the same exact thing. All right, just depends on your preference on how you want to write it. It's the same exact thing. All right. Number 6 is pretty basic. Rhombus. Number 7. Area of a rhombus. Area of a rhombus. Do you remember that? Well, it's the parallelogram, isn't it? Isn't a rhombus a parallelogram? So how do you find the area of a parallelogram? Just the base times the height, isn't it? Isn't there there's another thing with diagonals, isn't it? Yeah. It's the same thing as kite. I'm sorry. Well, it would be. I mean, if you knew the base and the height, but what if you couldn't find the base and the height? And on this I'm looking at, they do give you the diagonals on this one. So this is the same thing as a kite, correct? I was wondering why I got those spaces. But I was thinking back a little bit older, because a rhombus is a parallelogram, isn't it? So you could go base times height. But on this particular problem, there's no way to figure out what the base and the height are to this. All right, so you must know, they do give you the diagonals. So you can go D1, D2. So it's the same thing as a kite. And that's number 7. And that's real straightforward. Nothing, you don't have to find an extra special thing using trig or anything like that. That's real straight up, pretty easy. Okay, number 8. They're asking you to find the area of a square. Area of a square. And that would be pretty easy normally, because the area of a square, if you just know one of the sides, it's just the base times the height, right? Or one of the sides squared. Would you agree? But the thing is, they don't tell you the sides of this. What they'll tell you is they'll give you the apothem. So they give the apothem. And you should know what to do. Okay, so they give you the apothem length. Let's just make up one. Give me an easy number that we can use. 5. Okay, so let's say the apothem is 5. So let me get a square here just to kind of get you going. Probably going to give away too much here, but now remember, you can do the apothem if you have a regular polygon, don't you? Is a square a regular polygon? Sure it is, because all the angles are equal, all the sides are equal. And so where would the apothem be if you had a square? It would be perpendicular. It's from the center, right? From the center, perpendicular to any of the sides. So you don't have to go up and down, but it's probably the easiest thing to do, right? And they give it to you. What did we say? We just made this one up, right? We said it's 5. So if that's 5, what do you think you could do here? You can make a triangle. Okay, so where do you want to make it? From here to the corner? Okay. like that. Right? So remember, this was 90, right? This thing that goes here splits it in half. All right, so that must mean that's 45. So what's this length right here? That's 5. So what's the whole length of the square? It's 10. And so how do you find the area of the thing? You could do that. You could do that, but since you know it's a square, you already know, an easier formula. You can just do base times height, right? So this is 10, 10, 100. Wouldn't that be a little bit easier? You could go 1/2 the perimeter. What would the perimeter be? 40, then take half of that, right, and then multiply it by the apothem. So isn't that the same thing, right? That's 20, that's 100, so you still get the same thing. Yep. Mm-hmm. To go up there and make that 10. Yep. Yeah, you could have done that too. Exactly, because if I would have gone perpendicular to this one, yeah, that's actually probably a little bit easier, isn't it? So if that was 5, that would be 5. So the height is 10. You know it's a square, so you know that this is 10, this is 10. 10 times 10 is 100. Yep. You can do it that way as well. Good. We good with that? All right. Number 9. They ask you to find the area of a regular hexagon. Number 9. The area of a regular hexagon. Now, you don't have like a specific formula for a hexagon, but you do have a formula for any regular polygon. And we mentioned it once already up here, but let's do it now for the first time. What is it? 1/2 times the perimeter times the apothem, okay? And you're trying to find the area. So you got to find the perimeter of it, find the apothem, and they'll give you certain things, okay? They don't actually draw a picture on this one. They give it to you in words, but that's not that big of a deal, is it? So if it says regular hexagon, if you want to draw, a hexagon, you can, but do you really even need to draw the whole entire hexagon? Yeah, all you need to do is draw here, here, and you know the apothem's going to be somewhere in here, right? Would you agree? Okay, and if you wanted to draw this one, we'll try to make it look like that. Oops. Okay, and then what would you do? Take the apothem. That would go there, right? And what's it do to that side? It's perpendicular, but it also does what? Cuts it in half, right? And you could do this. And what would you do? Again, depending on what they give you, you could find this angle right here. How do you find that angle? If it's a hexagon, you do what? Right, 360 divided by 6. That's easy. What's that? 60. But is that angle 60? No. It's this angle right there. This whole big angle inside of here, that central angle, if you want to call it that, is 60. Okay? So you find this little tiny one. What's that one? That would be 30. Okay? And they'll give you stuff. They'll either give you the apothem. They might give you the length of one of the sides. Let's just say they give you the length of one of the sides is 10. We'll do that number again. All right? If they say one of the lengths of the sides is 10, then what do you know? You know that that's 5, don't you? You follow me on that? And now you could find the apothem, couldn't you? All right, you got a 30, 60, 90, or you can use a trig function if you really wanted to. But it's 30, 60, 90. This is the short side. What's the long side? It's 5 squared to 3. So you've got the apothem. You can find the perimeter very easily. So if this little bit is, remember the whole thing we said is 10. So what's the perimeter of the whole thing? It's 60, right? And then you take half of it, right, because of your formula, and then you multiply it by the apothem. Everybody with me on that? Yep. It's getting a little better now, isn't it? Yeah. Knowing how to find it, knowing the little tricks. What's the biggest trick to find this stuff? Is to find that angle right there. Always do that. Okay? Always find that angle right there. And how do you do it? You take 360 divided by how many sides you have. If it's a hexagon, it's 6 sides. So you divide it by 60. That's that whole thing. This apothem splits that angle in half, so you just take half of it. And now you're good to go, right? Sometimes they'll tell you the apothem, they won't tell you the length of the side. But that wouldn't be that big of a deal, would it? Right? If they told you the apothem and you didn't know this, You could still figure it out. Or sometimes they'll tell you the length of the side, and you got to figure out what the apothem is. All right? It all depends on what they tell you. I'm not going to completely give this away. I've given you enough already, so that's good enough. That was number 9. Number 10, now we're going circles. Going in circles. So number 10, okay, it's one of these deals. Let me get a circle here. Put a little dot right in the middle. Okay, it's that sector, the area of a sector of a circle. That shouldn't be that big of a deal to you, should it? Let's make up a number just for fun here. What do you think that angle is? 95. Okay, we'll say that's 95 degrees. And you wanted to find, and let's give a radius. Give me a number for a radius. Make something up. 5 again. Okay. So what if we wanted to find the area, just this shaded part, which is a sector? Right. 95 over 360. And then pi r squared. The r is 5. There you go. Plug and chug and you're good. Plug and chug. You haven't heard of that? I say that all the time. Some weird things? Is that weird? He says plug and chug? I got that from my calculus teacher in college. He always said that all the time. So I thought, if I'm ever a teacher, I'm going to say that. So I do. I've been saying it for 25 years now. So, yes.
So you're finding the area of that?
You're finding the area of it. Yes. Well, yeah, if it's like inches, then it would be inches squared. Okay, but the only thing you square in your formula is the radius. Okay, don't take your answer and then square it. Some people have done that. I've seen that. Okay? All right. Number 11. Number 11 and 12 is one of those deals where it's like a combination of different figures. Remember, we've been doing this kind of thing. Yeah, composite figures is what they officially call it. Like if you had a rectangle attached to a triangle or something. Again, I'm just making something up. What if you had... It's 11 and 12, yeah.
Can you just add them together?
Yeah, you find them both and you just add them together. Exactly. This is not even one where you leave stuff out. It's not even one of the ones where, you know, you find the area of the whole thing, then you find the area of the thing in the middle, and then you subtract to find the shaded part. This is just find the area of everything. So this whole thing would be shaded in. All right, it says find the area of it. So if this is a rectangle, you find this. This is a triangle, you find that. Add them together, and you got the whole entire thing. You okay with that? All right. So that's 11 and 12, actually. So there's two different shapes, but it's the same basic idea. We good? All right. Let's keep going. Number 13. Find the area of a rhombus. This is kind of, we've already dealt with a rhombus before, and it's doing it again. I don't know why they weren't together, but that's okay. It's just it's a word. It's not a picture this time. So I'll just write area of a rhombus. Okay. So number 13 would be the area of a rhombus as well. Yeah. They don't just come right out and give you the two diagonals. In that problem earlier when we talked about the rhombus, they did. They just came out and just said, you know, here are the two diagonals. They drew a picture for you. Here's the two diagonals. Find the area. That was simple. This is a little bit more complicated where you're going to have to find, you know, one of the numbers that they ask you that you need to know. So it takes a little bit of extra thought. But if you just know what the area of a rhombus is, and what it is again off the top of your head? 1/2 d1 d2. Okay. But also remember, a rhombus is also well, it's a parallelogram as well, right? So you may, I'm not really sure, I'm just reading it, I haven't done it in my head yet, but you may have to take that information and combine it, because it would also, and it's also what? The base times the height, isn't it? If you knew the base and the height. See, this is if you don't know the base and the height, so you use the diagonals, This is if you don't know the diagonals and you know the base and the height. Would you agree? So it all depends on what information that you know. So if I didn't know the base and the height and I knew the two diagonals, I would use this formula. If I didn't know the diagonals and I knew the base and the height, then I would use this formula.
So it's either or?
Well, it could be both. You might have to use one to find the other. Like you might have to use this information to find the height or something like that. Okay? So just be open-minded to that one. You have to think.
Like if they, like you're saying, if they were to ask for the height, like what side of the...
Yeah, you may use this. They may tell you one of the diagonals and that helps you find the height or something like that. Okay? I don't want to like just hand it to you. But just realize you have to think just a little bit more on this one. Okay? I don't even know if you're going to use a combination of these two. I just know that you have to think a little bit more on this one than them just telling you, here's the two diagonals, bang, find the area. Okay? All right. 14. Okay, it's another area of a rhombus problem. So 13 and 14 are area of a rhombus. Okay? I'll give you a little bit of a hint on this one. They tell you that one diagonal is twice as long as the other one. So let's go find a rhombus again. I think I have a rhombus over here. Here it is. And let's jump back down to where we were. Give me a second. Give me a second. There we are. Yeah, they say that one of the diagonals is twice as long as the other diagonal. All right, so I'll just give you a hint on how to start it. So this one's 14. They both deal with a rhombus. So it says one diagonal is twice as big as the other. So let's call the little one x, and we'll call the big one what? 2x. That's all. Okay? So that's your hint for number 14. That's all I'm going to tell you. So call the little one x, and it says if one diagonal is twice as big as the other, call the little one x, call the big one 2x. And then do whatever it asks you to do. All right? It still deals with area. Oh, they actually tell you the area too. They tell you what the area is, and then you have to find like the lengths of the diagonals. All right? They tell you the area. On number 14, they tell you what the area is. They give you a number. All right? They say this is the area. Find the lengths of both diagonals. Yeah, if you solve for x, that's one, and you just double it, and you got the other one. We good? Okay. Wow, practically gave that one to you. 15, we're going back to area of a circle again. But again, like before, like the first half of it, the area things were pretty easy, pretty basic. And now they're just the same equations and stuff. Yeah, it's just a little bit more complex. You got to just think a little bit more, okay, about this. So this one, they tell you the area of a circle. Area of a circle. So they actually give you the area of the circle. They give you the area of the circle. And you have to find, they actually ask you to find the diameter. Okay? Should be pretty easy, right? So what do you find first? Do you find the diameter first? Find the radius first, and then do what? Yeah, and then you double it to find the diameter. Okay? So they give you the area. Remember, the area of a circle is pi r squared. So they give you this, and you have to find this. Divide by pi. Yeah. Yep, I've given you too much. I shouldn't have given you that much. But there you go. All right? Aren't you glad you're here today to hear all this? I am recording it, but it's a little bit better in person, though, isn't it? So you can. All right. Let's see. Similar figures. Remember we did areas of similar figures? Areas of similar figures. Do you remember what the relationship was?
Oh, yeah, proportional, right?
Yeah, but more than just that. The areas. Yeah, I forget how we wrote it. Like,
You said that
like if I took, I forget how we actually write it, but remember you square the area?
areas are proportional to the square of the scale factor.
Okay, so here's your scale factor. We'll just call it A over B. All right, that's your scale factor. All right. So what are the areas? So we'll put capital A, capital B. So boom, boom, like that. Remember that?
Yeah, you said areas are proportional to the square of the scale.
The square of the scale factor. Sorry, my bad. Whew, my goodness. I messed up there, right. It's, yeah, you compare the areas, and that's equal to the scale factor squared.
Okay, yeah.
Right. So these are the areas, the capital letters, okay, and that's equal to the square of the scale factor. That's right.
If, like, the little a and the little b, will you square? Do you want us to reduce that before doing a whole equation, or does it not matter?
Doesn't matter.
It won't come out to a different answer?
No.
Okay.
No, you can just, whatever is easiest with your math, okay? Because they'll tell you one of these areas, right?
Yeah.
They'll tell you what B is, this, like, right here, and you just solve for A. So, I mean, you could square and simplify now if you wanted to. I wouldn't, though. I would just cross multiply, put all those, even put the square number, right? Write it as something squared, and then just stick it in your calculator that way. It all depends on you. It's personal preference on how you figure out what that is. Yeah. Number 17 is kind of the same thing. So 16 and 17 are basically the same. All right? They're similar figures. They're two different figures, obviously, but it's the same idea. So 16 and 17 kind of go together. All right? 18 and 19 are kind of the same deal. Oops. 19. That's ugly. Let's try that again. All right. So numbers 18 and 19. Oh, I scooched stuff over. How did I do that? There we go. Kind of running out of time. Let me just do this real quick. This is inside of a circle. So this is when you have a polygon inscribed in a circle and you want to find the shaded area. This is the kind where you actually have stuff inside the circle. So like if you had this, like you're finding the area of the shaded region. Yes, they're regular polygons for both of them, okay? And like all this is the shaded part. I didn't really draw this to scale or anything. This is just to give you an idea of what it's going to look like. Okay? So you'll have something in there, a triangle. You could have, well, I'll tell you right now, the first one's a triangle and the second one is it's a hexagon, okay? So what do? You find the area of the circle, you find the triangle, and then you do what to it? You subtract, and that gives you your shaded area. And that's all it is for 18 and 19. Okay? So 18 is a triangle, 19 is actually a hexagon inside of a circle. It's inscribed in a circle, which means the vertices hit right on the circle.
So you find the area of the triangle, find the area of find the area of
the circle, the triangle. The circle's the bigger one, right? So you take the bigger one minus the smaller one, and that's what's left over. Yep.
So the bottom side of that triangle is going to be your diameter?
Not necessarily. Like I said, I didn't draw this really to scale or anything. You have to figure that out. I got to leave something for you to do, right? I can't give you everything. So you figure out what the area of the triangle is. You figure out what the area of the circle is. Subtract the two, and that's your shaded area. So that's for 18 and 19. Again, 19 is a hexagon. I'm telling you right now. So go over hexagon. 6. So number 20. Last one. It seems kind of odd that this would go here. It's a rhombus again. And it's area of a rhombus again. Yeah. Seems kind of odd that it's there, but anyway. So again, it's area of a rhombus. There's no picture on this. It's just words. Area of a rhombus. They give you the area, okay? So they give the area, and you have to find some other stuff. And they actually give you one of the diagonals. So they give you one of the diagonals, they give you the area, and they ask you to find the other diagonal. Okay? Shouldn't be that big of a deal, should it? Yeah, it's easy, because you know the formula. That's actually pretty easy. I don't know, maybe I ran out of problems. I'm like, oh, I need one more problem to stick in there, and I just threw that in there. I can't even remember. So they give you the area. They give you one diagonal. You just have to find the other diagonal. That's a piece of cake. That should be easy. Well, I don't make up the problems. I find the problems from the book, worksheets, different places like that. I put them all together. Yes. All right, how's that? We good? All right. We can read off the answers real quick to that review thing you did. So we'll do that, and that's our review.